Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking and subscribing and sharing. Professor Van Hamlin, I'm going to cover the second derivative as a linear transformation, and we're going to go specifically degree polynomials of 3 or less as a linear transformation. And I'm going to call back the linear transformation. The first derivative from P2 to P1 is equal to, I'm going to define this as the derivative from degree 2 to degree 1 as this matrix here. And if you look back, I have a video on this. I'll try to link to this. Now we know that the derivative of this second degree polynomial is going to be equal to 7 minus 10x, and I can verify it if I write this polynomial as a vertical vector. 3, 7 minus 5. We can see as I multiply this, you're going to get 7, negative 10. So going from P2 to P1 as we expect, giving us the same thing. Now, we know that the basis of P2 is just a linear combination. This is 3 times 1 plus 7 times x minus 5 times x squared. And it's going to spit out a polynomial of degree 1 or less with, 7 times 1 minus 10 times x. And again, you can see it right here. Now, if I want to take the derivative that goes from P3, the first derivative, what I know is it's going to go from P3 down to P2. So in order to do that, what I need to do is I need to take the derivative on each one of these of these bases, and then I'm going to join those vertical matrices to create, one of these things, but it's going to be of a different size. Notice that this is a 2 rows and 3 columns. So what we know is that it's going to go from a third degree, or I should say a 3-dimensional vector space to a 2-dimensional vector space. So 3-dimensional down to a 2-dimensional. Now, when I'm doing this derivative of P3, what this is a 4-dimensional vector space, and it's going to drop down to a 3-dimensional vector space. So I'm expecting a 4 by 3 matrix. So we'll see this when we come back. All right, so let's do that. So what I need to do is I need to know the derivative of this. So what is the derivative with respect to x of, and I write this out kind of long ways, 1 plus 0x plus 0x squared plus 0x cubed. That's, this piece right here. And what I know is this is going to give me, we're going to say the derivative. So this is d of 1, 0, 0, 0. And this is going to give us just 0. Now remember, it goes from P3 to P2, in this order. So this is going to be 0, 0, 0. All right. Now, similarly, we're going to do the derivative with respect to x of, 0 plus 1x plus 0x squared plus 0x cubed. And this is going to be, d of, 0, 1, 0, 0. And we know that this thing's derivative is just going to give us 1, and then this will be, 1, 0, 0. And that's because I know the derivative of this is just equal to 0, and the derivative of this is just equal to 1. Remember that this needs to be of, this vector space. Now, the derivative with respect to x of 0 plus 0x plus 1x squared plus 0x cubed is going to be equal to, the derivative of 0, 0, 1, 0. And what we know is that the derivative of this thing is going to be a 2x. And remember that this first is going to be your constant here. This is going to be your x, and this is going to be your x squared. So we know we're going to get 2x back, so it should look like this. This is, again, equal to 2x. And then finally, the derivative with respect to x of 0 plus 0x plus 0x squared plus 1x cubed. We know this is going to give us a 3x squared. So writing this in this form, 0, 0, 0, 1, is going to give us a 3x squared, and that's all I'm going to get. So this is going to be 0 here, but 3 of these. So 0, 0, 3. That represents 3x squared. All right, now that means that this derivative matrix that goes from polynomials at degree 3 to polynomials at degree 2 is going to be the adjoint of these things. So this together. So 0, 0, 0. This is 1, 0, 0. This is 0, 2, 0. And finally, I have 0, 0, 3. And what's nice is we can do it like a real quick check. Like, let's just do a quick check. What is the derivative with respect to x of 5 minus 3x plus 2x squared minus 6x cubed, for instance? Well, if I take this thing's derivative, this will be 0, this will be minus 3 plus 4x minus 18x squared. Now, that means if I multiply this matrix, so this should also work as 0, 1, 0, 0, 0, 0, 2, 0, 0, 0, 0, 3. And if I multiply it by, this thing in vertical form, 5 minus 3, 2, and, negative 6, what I can see is when I multiply this first row times this column, I'm just going to get, minus 3. Second row times this column, I'm going to get 2 times 2, which is 4. And then third row times this column, I'm going to get, 3 times negative 6, which is minus 18, which is going to be the same. These are the coordinates or the coefficients to, this second degree. So negative 3 times this plus 4 times this minus 18 times this, which is right here. Bam. All right. Now our real goal was to, create the derivative that goes from polynomials of degree 2 down to polynomials of degree 1. Essentially, I want to take the second derivative. So what we know, I want to know what is the derivative, the second derivative with respect to x of this 5 minus 3x plus 2x squared minus 6x cubed. Now I know that the second derivative is going to be the derivative of the derivative with respect to x of this 5 minus 3x plus 2x squared minus 6x cubed. And I know that doing this part right here, this is going to be equal to, the derivative with respect to x of, well, we just did this. It's right here. This is going to be equal to minus 3 plus 4x minus 18x squared. And now I have to take its derivative again, and the derivative of this will be 0. This is going to be equal to 4, and this is going to be minus 36x. Okay, now I want to build a matrix multiplication for the second derivative, and what I know is this is the matrix that goes from degree 3 to degree 2. This is the matrix that goes from degree 2 to degree 1. So how do we set up this this second derivative? Well, we know it's the derivative of the derivative. Now remember, this inside derivative is the derivative that goes from P3 down to P2. So let's do the underlying thing first. Well, I'm going to need the derivative that goes from degree 3 to degree 2 of, let's write this in vertical form, so this is going to be equal to 5 minus 3, 2, and then negative 6. Now we already know, this is just this thing right here. Multiply this. I already know its answer, but I'm trying to build the matrix right now. So now I'm going to have to take, the derivative of that thing. Well, this derivative takes degree 2 down to degree 1, so it's going to be this thing. So now I'm going to have to take, the derivative that goes from 2 to 1 of this particular derivative. So now when we write this, this is going to be equal to, let's move this out of the way, 4 minus 36x, just in case we need the room. Well, this, we know that we can, this is a matrix, this is a matrix, this is a matrix, and they're associative. So what I can do is I can go, D21 times D3, 2, and then I can multiply by that matrix last. So our whole goal is when I multiply these two matrices, this is going to give us that that second derivative of polynomials of degree 3 or less. So this is going to be equal to degree 2, 1. This is 0, 1, 0. This is 0, 0, 2. And then I'm going to have to multiply it by this matrix, which is 0, 1, 0, 0. This is 0, 0, 2, 0. This is 0, 0, 0, 3. Let's see if this will even work. Well, this is, a 2 by 3, and this is a 3 by 4, and this will work. These match, so I'm going to get a 2 by 4 matrix back here. And let's see what we get. So this row times this column is going to give us, 0. This row times this column is going to give us 0. Top row, third column is going to give us 2. Top row, fourth column is going to give us 0. All right. Now, second row, and then by the columns. Second row, first column is 0. Second row, second column is going to be 0. Second row, third column is going to be equal to 0. And then second row, fourth column is going to be equal to 6. And this is going to be I'll call it the derivative that goes from degree 3 to degree 1 now. Notice that this is a 2 by 4 matrix as it's supposed to work, and let's multiply this. So this is going to be equal to 5 minus 3, 2, negative 6. And the hope is that we're going to get this polynomial back. Well, this is, it should be 2, right? So this is, this is a 2 by 4 multiplied by 4 by 1. So this is going to be equal to 2 by 1. This is looking pretty good. All right, let's multiply. First row, that column. Well, 0, 0, 4, 0. So this will be 4. And then this row times this column, well, this is going to be 0 times 5, 0 times this, 0 times this. 6 times negative 6 is minus 36. So indeed, we actually got that polynomial that we were looking for, which makes this polynomial that second derivative. So if you like the content, please subscribe.